Hello everyone. After you have completed the topic of wind circulation and the ocean water properties, so I thought today to discuss something on the surface ocean circulation. Though I have already uploaded a video on my channel regarding this, but then I realized that whatever I have written in that class on the board is not very visible. So what you can do is that you can use the audio in that lecture, and then of course you can use this video also, which I'm going to make. Then that will help you to clear your concepts. So let us begin. The surface ocean circulation. So we all are aware that the earth, which is 75% covered by water, it has not more than 2% potable water or fresh water. The 98% of the total water content on the earth is locked up in the mighty oceans. There are five oceans together, but the major ocean bodies are three, which are mentioned here. So, if we go from the first diagram, the ocean which separates these two uh, land masses, the African and some part of the European continent from the North and South American continents, it is called as the Atlantic Ocean. The Atlantic Ocean has its spread in both the hemispheres. So we have the Northern Atlantic Ocean and the Southern Atlantic Ocean. The second diagram, it shows up the Indian Ocean. The Indian Ocean, it separates the East Asian part from the African region. And yes, of course, the Australian portion is also there in the Southern Hemisphere. The Indian Ocean is unique in one condition, that it is a it is an ocean which does not have the northern hemisphere component. Rather, these two water bodies, this is the Arabian Sea and this is the Bay of Bengal. So if we speak in a strict sense, then Indian Ocean is only in the southern hemisphere. But then while talking about the Indian Ocean, and then sometimes we loosely refer to as the Northern and Southern Indian Ocean. But if you go by the strict definition, then Indian Ocean is not in the Northern Hemisphere. These are the Arabian Sea and Bay of Bengal. The third and the largest ocean is the Pacific Ocean. This diagram itself shows the extent of the Pacific Ocean. Pacific Ocean. So you can realize over here that the aerial extent of Pacific Ocean is the largest, and it also has northern Pacific Ocean component and the southern Pacific Ocean. In all these three diagrams, you can see a portion over here in the southernmost margin. This portion which separates Antarctica from rest of the continents. This blue marked by the blue color that marks the temperature over here. So this particular ocean, it is called as the Southern Ocean. So how do we define Southern Ocean? It is the southernmost part of the Atlantic, Indian and Pacific Oceans. While in the north, near the Arctic region, there is the Arctic Ocean. So, Arctic Ocean and Southern Ocean, they both are the polar oceans. That is why I said there are five oceans altogether, but the major oceans are three. The main oceans that control the global dynamics of climate and other things, they are the Atlantic Ocean, Indian Ocean, and Pacific Ocean. So, some facts and figures that the Pacific Ocean, it is the largest ocean, while Atlantic Ocean, it is the most saline ocean. Most saline ocean. And the reasons for this have already been discussed several times by me, and you can see the videos of on my YouTube channel, and then you can get about why the Atlantic Ocean is the most saline ocean. Also, the Pacific Ocean is the oldest of the existing ocean basins. So Pacific Ocean is also the oldest ocean. There is a video on the Wilson cycle that I have uploaded. Please go through that. Okay. Atlantic Ocean is the ocean where the deep ocean circulation starts, begins. Okay. So these are few facts and figures which you should always remember about the ocean, that the oldest and largest ocean is the Pacific Ocean, most saline ocean is the Atlantic Ocean, deep ocean circulation begins in the Atlantic Ocean. Indian Ocean is a unique ocean where there is no northern component, it is only the southern component. That is why we say Indian Ocean, and we do not use the words northern Indian and southern Indian Ocean in strict sense. Okay. So once I have given you this uh, fact about the different types of ocean, of course, yes, the Southern Ocean is the southernmost component of these three main oceans, and the Arctic Ocean is the uh, ocean in the Arctic region. So we have two polar oceans, the Arctic Ocean and the Southern Ocean, and these three. So in all, we have five oceans. So coming to the ocean circulation, the ocean circulation is of two types. First is the surface circulation, and the second one is the deep circulation. As the name suggests, the surface circulation, it operates on the surface of the ocean, and the driving factor for the surface circulation is the winds. So the way the winds move, they will drag the water with them, and that forms the surface ocean currents. While the deep ocean current or the deep circulation, it is because of temperature and salinity of the sea water or the ocean water. And therefore, this the deep ocean circulation is also referred to as thermohaline circulation. Thermohaline circulation. Also, you should remember that the surface circulation, if this is the northern hemisphere, the surface circulation, since it is operated by the winds, the ocean currents, the surface ocean currents, they may flow across the latitudes. They may flow across the latitudes. Okay. So this is the surface ocean circulation. While the deep ocean circulation, it is not the latitudinal type of circulation, rather, it is a meridional circulation. So meridional circulation means that it operates along the longitudes. Sorry, it operates along the longitudes. So the surface circulation, it operates across the latitudes, while the deep ocean circulation, it operates along the longitudes in the deeper depths of the ocean. Okay, this is the basic difference between the surface circulation and deep circulation. And yes, of course, once we will deal with the uh, thermohaline circulation, then you will come to understand that it is not strictly like it does not cross the latitudes, but then the main type of flow in the deep ocean circulation is the meridional flow. Meridional flow, while this is the across latitudes, latitudinal flow. So today we will be talking about the surface ocean circulation. So we came to know this fact that wind circulation is very important for the ocean, surface ocean circulation or surface currents, surface ocean currents. So that is why before going to the deep, oh sorry, before going to the surface ocean circulation part, you must be well aware of the wind circulation pattern. So if you watch the previous videos on wind circulation pattern, atmospheric circulation, you will come to know that there are three cells which operate. First one is the Hadley cell. Hadley cell operates from 30° north to 30° south latitude. It starts at the equator. Then there is the Ferrel cell, which operates from approximately 30° north to 60° north and 30° south to 60° south. While the last one is the polar cell. Polar cell, it operates roughly between 60° north to 90° north and 60° south to 90° south. And then there are different types of winds. There are trade winds, trades, which essentially have a direction from east to west. Therefore, the trade winds are also called as easterly winds. Easterly winds. Remember, whenever we talk about the nomenclature of winds, then the winds are named according to the direction from which they start. So the trade winds, they start in the east and they go towards west. That is why they are called as easterly winds. Second type of winds, they are the westerly winds. Westerly winds, as the name suggests, they initiate in the west and go towards east. While the third type is again an easterly wind, but it is typically named as polar easterlies. The polar easterlies, they operate from the poles and they again go from east towards west. So we have to understand this, that imagine a bucket of water and you blow air on the surface of the bucket. So if you are blowing air in this bucket of water from this side, then the water in this bucket will start flowing towards this side. It is very obvious, very common. So if the wind is coming from east and it is going towards west, the ocean current will also follow the same path. But then, just in order to give it a separate name, this ocean current is named it just oppositely to the winds. For example, if the wind is coming from east and going towards west, the wind will be called easterly wind. And the ocean current will also start from east and go towards west, but that ocean current will be named as westerly ocean current. Keep this in mind, that an easterly wind will generate a westerly ocean current, but the direction of motion of both the wind and as well as the current will be same. That I'll repeat it again, that if the wind starts from east and goes towards west, it is called an easterly wind. The water will flow along with the wind and it will start from east and go towards west, but that water, that current, ocean current, will be named as westerly ocean current. So I hope it is clear to everyone. Okay, so in this map I just wanted to draw the uh, distribution of the wind belts. So let us just quickly write the latitudes over here. So this is the equator, 0 degree, 10, 20, 30, 40, 50, 60, 70, 80, and then this one is 90. Similarly here, 10, 20, 30, 40, 50, 60, 70, 80, and 90. All right. So now if we have to superimpose the winds on this, then the trade winds, they start from 30-degree latitude and then they come towards the equator like this. They converge here. So these winds, they are known in both the hemispheres. So let me draw it in both the hemispheres first. This is very important to know the direction of the wind and which latitudes they operate in. So these winds, they are typically known as trade winds. Then the next type of wind, which goes from 30 to 60 degrees in both the hemispheres, it is called as the westerlies. So you can see that these winds, they start from the west, they go towards the east. This way. And similarly over here, in this way. So these yellow colored lines, they mark the westerlies. And the third type of winds that I told was the polar easterlies. The polar easterlies, as the name suggests, they again start from the polar regions and they go from east towards the west. This green color, they mark the polar easterly winds. Similarly here, now if you have any doubt regarding the direction, that why I am drawing it this way, then you have to keep in mind the Coriolis effect. Okay. So this is roughly the latitudinal distribution of the winds, the wind belts. So we have three types of winds: trade winds, which are basically the tropical easterly winds. Then we have the westerly winds and the polar easterly winds. Now, if I am to ask you this question, that what do you think? In which direction in which direction these winds will drag the water with them? So it is very obvious that the trade winds, they will bring all the water from east towards west side, because they are going towards west, right? Like this. The westerly winds, they will drag the water in their path from west towards east, this way. And same, the easterly, polar easterlies, they will drag the water from east towards west like other winds. So this is very obvious. Keep this in mind. Now, this is a projection of map I have drawn to show you two things. First, the extent of the oceans. If you see here, as compared to the oceans, the land mass is just 25%. And interestingly, the oceans, which are three types, they are named that there are three oceans. They seem separate, but all the oceans are connected. Okay, so this is, you should remember that oceans are all connected. uh, Connected. All right. So what is the effect of winds on water movement? So now I have already shown in this, but let me just draw it for you from over here, that this is the equatorial latitude, equator, 0 degree. So 10, I have written it over here. Now the trade winds, this is 30 degrees. So this is the direction, this is the latitude from which the trade winds operate. So trade winds, if they are coming this way, then what they will do, they will bring all the water in their path towards the west side, like this. So we can see here that all those areas where the trade winds operate, in the latitudinal extent of trade winds, they will drag all the ocean water from east towards the west side. Okay, so first type of ocean current, which is generated by the trade winds, it goes from east towards west. So we have a westerly ocean current generated by the trade winds. Then we have the westerlies, which go from 30 degree to 60 degree, this way. So what they will do, they will drag all the water from west towards east, this way. And of course, yes, this will happen in both the hemispheres, so don't get confused. This way, this way, like this. Okay. And then second type of ocean currents, it is from west to east. It is first one is under the impact of trades. Second one is under the impact of westerlies, and the third one, the polar easterlies. The polar easterlies, as the name suggests, it will again bring all the water from west to east. From east to west, sorry, from east to west. East to west, like this. Okay. So the third type is again from east to west, and it is under the impact of the polar easterlies. Okay. So the effect of wind on water movement is this. In this map, I just tried to show that how the winds will drag the water of different latitudes in different directions. Now, this is a map of the sea surface temperature. Sea surface temperature. We all know and we all have read about the latitudinal distribution of temperature. So we understand this fact that the low latitudes, the tropical latitudes, have a higher temperature than progressively higher latitudes. Means as we go from tropics to temperate and then to poles, the temperature of the water goes on decreasing. Now, the currents that operate in the tropical regions, like this, like this, these. all these currents operating in the tropical regions, tropics, all these currents, they will definitely be having warmer waters. They will be carrying warmer waters. So such currents which operate in these latitudes, they are called as warm currents. Warm currents. Why warm currents? Just because they carry warm water. Now, we can see here that under the impact of winds as well as the variation in the sea surface temperature, normally, forget about the exceptional cases, normally these warm currents, they go from low latitude towards higher latitudes. We'll come to it why this happens. Low latitude to higher latitude. Now, all those currents which operate in the temperate and polar regions means which are responsible for the flow of cold water. Such currents, they are called as cold currents just because these currents, they carry cold ocean water, cold currents. Okay. So normally going across the latitudes, these cold currents, they transport the water from high latitudes towards low latitudes. I hope this is all clear that whenever the current, it transports warm water, it is called as warm current. Transports cold water, it is called as cold current. And the movement of these currents under the impact of winds and how they transport that water. So they may go from low latitude to high latitudes carrying the warm water, and they may come from high latitudes towards low latitudes carrying the cold waters. Okay, so I hope it is clear that now the currents, the ocean currents, they have different, abilities to carry the waters of different temperatures, and that is why they are named accordingly. So in different, remember this, that the ocean currents are named on the basis of their geographical location. So we'll see how they are named. Now this is a very interesting thing. How much water is carried by an ocean current, and what is the unit to measure the ocean currents? Does it carry one bucket of water, two buckets, thousands of liters? How much amount of water is being carried? So to understand this, we have to realize that the ocean current, we have to assume the ocean current like a cylindrical body, because it's not that the ocean currents just run on the surface, but they have impact at till some depth as well. So if we talk about the ocean currents and try to draw it, it would look somewhat like this. This is how an ocean current looks like. Okay. So the ocean current, the surface ocean current, not merely runs on the surface, but it has some depth as well. So this is the depth of the ocean current, means it may operate from the surface till this depth, and then there is some width of the ocean current, width of the ocean current, how wide it is. So the depth and the width of the ocean current, they give us the cross sectional area. So if this is the width of this cylinder, and then we have the depth of the flow, then it gives us the cross sectional area. And once we multiply that cross sectional area with the velocity of the current, we will get how much amount or how much volume of water is being transported by that current per second. So it may happen that an ocean current may carry that much amount of water per second, which may be equal to the water of all the rivers of the world combined. It may be that huge a current. Okay. So the unit to measure this, the volume of water transported by an ocean current per second, is called as Sverdrup, Sverdrup, also written as SV. SV. It is Sverdrup was an oceanographer, and in his honor, this unit is given. Sverdrup, SV. So 1 SV is equal to 10 to the power 6 meter cube per second. So you can imagine how huge this value would be. In so if we say that an ocean current is carrying 1 SV of water, it means it is carrying 1 million cubic meter of water per second, or 10 lakh meter cube of water per second. So you can understand how strong or what is the capacity of these currents to flow and uh, carry the water. Let us try to calculate one. So let us say that width of a current is, let us say, 10 kilometers, and its depth of flow is 2 kilometer, and the velocity of this current is, let us keep it simple, 1 meter per second. It is saline water flowing. So if we wish to now find out what is the volume of water being carried by this fictional ocean current, first let us calculate the cross-sectional area. Since the velocity is given in meter per second and one Sverdrup is in meter cube per second, we need to convert the width and depth of the flow to meters, not in kilometers. So what we will do, 10 into 10 to the power 3 multiplied by 2 into 10 to the power 3. That becomes 20 into 10 to the power 6 meter square is the area of that current. Now the volume of water is equal to 20 into 10 to the power 6 into 1. It will be meter cube per second. We multiply this meter by this meter square, it becomes meter cube. So it becomes 20 million cubic meter per second, or 20 SV, 20 Swedra. So if we say that an ocean current which is carrying 20 Swedrup of water, it means it is transporting 20 million meter cube of water per second. I hope this is clear. So now if any of these two entities are given, you can easily calculate the third one. Say for example, if an ocean current is carrying 20 Swedrup of water and its velocity is 1 meter per second. The depth of flow is 2 kilometers, then find the width of that current. Or the Swerdrup value is given, depth of flow is given, and width is given. You are asked to find out the velocity of that current. You can easily find out with this. So time and again in oceanography, you will always be coming across this SV value. That is why it is important to know how to measure this SV value. There are currents which carry up to 200 SV of water. So if I say 200 SV, you can imagine that 200 multiplied by 10 to power 6 meter cube per second, which means how huge that current would be. We have the example of this current. I'll come across it. All right. Now let us come to a very important concept of boundary currents. Always remember that whenever we talk of boundaries, then the oceans also have boundaries, and continents also have their boundaries. So let us talk about this North American continent. This, where I am drawing arrow now, this is the eastern boundary of this continent, and this is the western boundary of this continent. On the other hand, in the Atlantic Ocean, the this side where this yellow arrow is pointing, it is the western boundary of Atlantic Ocean, and towards the European side, it is the eastern boundary of the northern Atlantic Ocean. So what does this mean? It means that the western boundary of an ocean, it coincides with the eastern boundary of continents. You can see see this across the globe. This is the western side of Pacific Ocean. This is the western side of Indian Ocean, and they are coinciding with the eastern side of landmass, eastern side of Africa, like that. Okay. So always remember, when we are talking about the boundary currents, then never get confused when I use the words like western boundary current and eastern boundary current, that they have specific meaning. So the boundary currents basically are of two types: the eastern boundary currents and the western boundary currents. But remember, let us make it abbreviation EBC and WBC. EBC is the eastern boundary current, WBC is the western boundary current. But remember, this is not the eastern and western side of continents. This is the eastern and western side of the oceans. So when I say a current is an eastern boundary current, it means it is operating on the eastern side of ocean. So this current will be EBC. If I say an ocean current is a western boundary current, it means it is operating on the western side of the ocean. That will be WBC. So the eastern boundary currents, they flow across the western side of the continents, while the western boundary currents, they flow across the eastern side of the continents. I hope this is clear to everybody. Okay, now let us come to the different types of eastern and western boundary currents. Okay, let us first talk about the largest ocean, that is the Pacific Ocean. The first current, the first important current that flows across the equator, along the equator, not across the equator, along the equator, under the impact. So I am drawing the winds on the land masses. So that we get a lot of space for oceans. So here, this is equator. So this is 10 degree, 20 degree, and this is the 30-degree latitude. So these are the trade winds. We have these trade winds. I'll draw on all the continents over here. Trades, all these are the trade winds. Under the impact of trade winds, in the northern hemisphere, we get an equatorial current which flows along the equator from east towards west. This equatorial current, which is flowing in the northern hemisphere, it is called as north equatorial current. Similarly, there are trade winds in the southern hemisphere as well. So we have again one more equatorial current now, which is in the southern hemisphere. It is called as the south equatorial current in all the oceans. South equatorial current. So the common feature of north and south equatorial currents is, first, it is generated by the trade winds, and second, both these currents, they have the flow of the direction of flow from east towards west, and then they flow along the equatorial latitude. That is why they are called so. Now, in the Pacific Ocean, there is another current which flows from the tropical latitude and it goes all along. This current from this latitude and goes like this. This current is called as Kuroshio current. Kuroshio current. In Japanese, the word Kuro means black and Shio means current. So this Kuroshio current is a current which has dark colored waters or black waters. An interesting fact for this current is that this current, Kuroshio current, it goes along the western side of the Pacific Ocean, North Pacific, western side of the North Pacific Ocean, Kuroshio current. So, Kuroshio current is a type of western boundary current. Okay. Then come to the Atlantic Ocean. In the Atlantic Ocean, from the Gulf of Mexico, from over here, flows a current which goes all across from low latitudes towards the higher latitudes. It is called as Gulf Stream. Very famous current, Gulf Stream. The Gulf Stream also flows along the western side of the Atlantic Ocean. So it is also a western boundary current. Now let us, and as I have already told you that there is no uh, uh, northern component of Indian Ocean, so we'll skip for that. Now let us come to the southern hemisphere oceans, the southern Pacific Ocean. Southern Pacific Ocean has this western boundary current flowing across the western side of the South Pacific, while eastern margin of Australia, this current is known as East Australian current. Australian current, but yes, again, it is a western boundary current. You can see here because it is flowing on the western side of Pacific Ocean. In case of South Atlantic, there is a current which goes across the Brazilian coast, but the Brazil coast is the eastern side of South America, but this side of the ocean is the western side. So this current, which is the Brazil current is again a western boundary current. Now we have the western boundary current in the Indian Ocean as well. This current which flows along the coast of Africa, this current is known as Agulhas current. Agulhas current is also a western boundary current. So if you see over here, all the western boundary currents have one thing in common. That is that these currents they flow from low latitudes to high latitude. And we all understand this that in the low latitudes the water temperature is warmer. It means that the western boundary currents will be transporting warm water. Warm. So western boundary currents, they are warm currents. Okay. So I hope you understood this. So if you see over here, the different currents, the Kuroshio current, the Gulf Stream, I'll show all these to you in the website earth.nullschool.net. But first, let me finish this. You can see here that Agulhas current is going from close to equator towards higher latitudes, towards the poles. So the western boundary currents, they have a poleward movement. Poleward movement means they go from low latitudes towards the polar latitudes. Now let us come to the eastern boundary currents. Again in the North Pacific Ocean, along the western margin of North America, Near the states of California and all, there is a current which comes towards the latitude, towards the equatorial latitude. It is called as the California current. California current. It is an eastern boundary current. Why eastern boundary? Because the California current is operative on the eastern side of the Pacific Ocean. In the northern Atlantic Ocean, this current it comes near the Canary Islands, which is which is in the eastern side of the North Atlantic. This current is called as Canary current. It is again an eastern boundary current. Let us come to now the South Atlantic. This current over here flows from the higher latitudes to lower latitudes along the Benguela region. This current is called as Benguela current. It is an eastern boundary current because it flows on the eastern side of South Atlantic. Then we have the Peru current or Humboldt current. Humboldt current, it is again an eastern boundary current. And in the Indian Ocean, there is the this is the current which flows along the western margin of the Australian continent. Therefore, it is called as West Australian current. West Australian current is also eastern boundary current. So we saw that in all the oceans we have the eastern boundary currents. And all the eastern boundary currents, they have one thing in common, that they flow from high latitudes towards low latitudes. That is, they have an equator-ward movement. Secondly, that all these eastern boundary currents, they flow from high latitude towards low latitude, which means they will be transporting cold waters. So essentially, the eastern boundary currents, they are cold currents. Cold currents. So I hope you understood this. Of course, there are always some exceptions. Okay, that are always there, but we'll not discuss today those exceptions. Let us come to the generalized things. So in all the oceans, we saw that the equatorial currents are operative. The north equatorial current in the northern hemisphere and south equatorial current in the southern hemisphere. The north and south equatorial currents are the direct result of the trade winds. Trade winds. And then the water which is being carried by the currents along the western margin of or western boundary of the ocean, they are called as western boundary currents, and they are warm currents. They transport warm waters from lower latitudes towards the higher latitudes, while the eastern side of the oceans or eastern boundary of the oceans, it has the currents which travel from high latitude towards low latitudes, and they transport cold waters, and they are called as eastern boundary currents. Now you can guess the importance of these currents, because imagine if Kuroshio current or Gulf Stream were not present, or they were not transporting warm water to the high latitude regions, like regions here, like here in these latitudes, then these areas would have been under permanent cold conditions. Now, the specific heat capacity of water is quite high, you all know. So, when this warm water is being carried from low latitude to high latitude, then it makes the climate of those regions conducive enough for population to survive. Okay, so this is the eastern and western boundary currents. So this is the ocean current map. In this, you can see what I just told you. In the equatorial latitudes, there is the north equatorial current in all the oceans, you can see here, and south equatorial current in all the oceans. The north and south equatorial currents, they have this direction from east to the west. In the Pacific Ocean, there is the Kuroshio current and in the northern Pacific, Kuroshio current is the western boundary current. In Atlantic Ocean, the Gulf Stream is the western boundary current. While in the southern hemisphere, South Atlantic, Brazil current is the western boundary current. Agulhas current is the western boundary current in the Indian Ocean, and East Australian current is the western boundary current in the South Pacific Ocean. Once we come to the eastern boundary currents, the California current is the eastern boundary current in the North Pacific, while the Peru current, which is also called as Humboldt current, is the eastern boundary current in the South Pacific. In the northern Atlantic Ocean, the Canary current is the eastern boundary current in the northern Atlantic, while Benguela current is the eastern boundary current in southern Atlantic. And in Indian Ocean, the West Australian current is the eastern boundary current. Now, there is another very important current, the Antarctic Circumpolar current. If you can see over here, this current, the Antarctic Circumpolar current. Antarctic Circumpolar current, also known as ACC or West Wind Drift. It is a current which encircles the entire Antarctic continent. You can understand this that the direction of Antarctic circumpolar current is from west towards east. It means that it is under the impact of the westerly winds. And this current, it circles the entire Antarctic continent. This is the largest ocean current. We will come to it in a while. Now, another important fact which you can mark over here is that in all the oceans, there is formation of ocean gyres. Gyres means circular motion, like this. So if you be careful in this North Atlantic Ocean, we have four currents: Gulf Stream, North Atlantic Drift, Canary Current, and North Equatorial Current. So these four currents are making one circle. In South Atlantic, we have the South Equatorial Current, the Brazil Current, the Antarctic Circumpolar Current, and the South Atlantic and the Benguela Current. These four currents, they are making the full circle. In Indian Ocean, that is in the southern hemisphere, the South Equatorial Current, the Agulhas Current, the Antarctic Circumpolar Current and its counterpart, the South Indian Current, and the West Australian Current, they are making one full circle. While in the Northern Pacific, we have the North Equatorial Current, the Kuroshio Current, North Pacific Current, and the California Current. They make one circle. While in the Southern Pacific, the South Equatorial Current, the East Australian Current, the South Pacific or the Antarctic Circumpolar Current, and the Peru Current or the Humboldt Current. This is making one full circle. So we see here that in all the oceans, there is the formation of these gyres. I'll just discuss these currents of each ocean one by one and then we will get these gyres. First of all, let us discuss the Indian Ocean. So, as previously mentioned, in the Indian Ocean, we'll not talk about the Bay of Bengal and Arabian Sea part. We'll discuss only the typical Indian Ocean. So, the current that flows along the equator, it is called as South Equatorial Current. The South Equatorial Current, it transports warm water towards the western side. western side of the Indian Ocean. This water, it piles up over here. It makes a pool over here. It has stopped. So this water gives rise to a warm current this way. This water gives rise to a current. This current is known as Agulhas current. Agulhas current. And if you remember, previously we saw the Antarctic circumpolar current, which was going this way. So this is Antarctic Circumpolar Current ACC, and some part of it goes in the Indian Ocean as well. It is called as the South Indian Ocean Current or Indian Ocean Current. Or let me remove this. You just remember about the ACC only. So sorry for this. ACC, Antarctic Circumpolar Current. And then there was one current which was a derivative of this, and it was flowing like this. This current was, wait, a bit higher. This current which was going from the higher latitude towards lower latitude along the western side of the Australia, it is called as West Australian current. So we can see these four currents over here. These four currents, they are the South Equatorial Current, the Agulhas Current, the Antarctic Circumpolar Current, and the West Australian Current. So these four currents, they make what we call as the Indian Ocean Gyre. Indian Ocean Gyre. So if a question is asked, what are the four currents that make up the Indian Ocean Gyre? Then these are those four currents: South Equatorial Current, Agulhas Current, Antarctic Circumpolar Current, and West Australian Current. So if it is asked that which is the northernmost current of Indian Ocean Gyre, then answer will be the South Equatorial Current. Which is the western current of the Indian Ocean Gyre? Agulhas current. Southernmost is Antarctic Circumpolar Current, and easternmost is the West Australian Current. What happens to these currents or in these ocean gyres in the peripheral and the central portion have already been discussed in the previous videos uploaded by me. We can take up this later. But as of now, you should remember this, that we have these four currents operated, four major currents. Of course, there are several other currents, but these are four major currents. If you remember, I had told you about one more current which operates in this region, which was the Somali current. Somali current is unique in one sense that it is a reversible current, that once the winds go from southwest, that is during the southwest monsoon, the Somali current flows like this. The Somali current flows like this from uh, south towards north. While once the northeast monsoon sets up, the Somali current reverses its direction and goes from north to south. So this is one current, but no, don't bother about it. Just out of sheer curiosity, I told you about the Somali current. Now, if we come to the Pacific Ocean, there are two uh, parts in the Pacific Ocean, Northern Pacific and the Southern Pacific. So let us first talk about the North Pacific. In the North Pacific Ocean, which is the huge ocean, along the equator flows the North Equatorial Current. This North Equatorial Current, it brings lot of warm water which piles up on the western side of the Pacific Ocean in both the hemispheres. So this is called as Western Pacific Warm Pool. I had discussed about it in my previous videos. You can have a look. From these Western Pacific warm pool is generated a current which flows like this, goes to the coast of Japan, and then turns over here. This is a warm current, western boundary current, which is called as the Kuroshio current. The water of the Kuroshio current is further dragged in like this. It is called as North Pacific current, and then the returning arc, the returning current over here, this is called as the California current. So, in the North Pacific, we get these four currents which make up the North Pacific gyre. North Pacific gyre. What are those currents? We have the North Equatorial current, the Kuroshio current, the North Pacific current, and the California current. So this is North Pacific gyre. This is the equator over here. Now let us look at the Southern Pacific Ocean. In the Southern Pacific Ocean, again, the equatorial current operates. It is called as South Equatorial Current. It also adds water to Western Pacific warm pool. This warm pool gives rise to a western boundary current which flows on the eastern side of Australia. So it is called as East Australian current. And then again, you remember the largest current, that is the Antarctic Circumpolar current, ACC. And on the eastern side of the South Pacific Ocean, the coast of South America flows this current which is called as Peru Current or Humboldt Current. So again we get these four currents which operate in the Southern Pacific Ocean. They are South Equatorial Current, then East Australian Current, Antarctic Circumpolar Current, and Humboldt Current. This gives us the South Pacific Gyre. South Pacific Gyre. So we get both these ocean gyres in the Pacific Ocean. Now let us look at the Atlantic Ocean. So in Atlantic Ocean, again there are two components, the North Atlantic and South Atlantic. So the equatorial current which operate in the North Atlantic is the North Equatorial Current. The North Equatorial Current water, the warm water over here, it keeps on piling up in this region, the Gulf of Mexico here, like this. And then this pool of water gives rise to a fast northward moving current which is called as Gulf Stream. The Gulf Stream is a western boundary current. Under the impact of the westerly winds, the Gulf Stream is further carried north. It is called as North Atlantic Drift. And then there is an eastern boundary current which comes from this side. This current is called as Canary current. So it's also, I'm writing as CC. Don't get confused. In Pacific Ocean, the CC is California current. Here it is the Canary current. So in the North Atlantic Ocean, we get the North Atlantic gyre as North Equatorial Current, as Gulf Stream, as North Atlantic Drift, and Canary Current. This is the equator. If we talk about the Southern Atlantic Ocean, then we have again the South Equatorial Current, then a warm western boundary current flows along the Brazilian coast. We call it as the Brazil current. Then again, remember the largest ocean current, that is the Antarctic Circumpolar Current, and a cold eastern boundary current which comes on this side near the Benguela region. It is the Benguela Benguela current. So this gives us the South Atlantic gyre. South Atlantic gyre. It has South Equatorial Current, Brazil Current, Antarctic Circumpolar Current, and the Benguela Current. So I hope you understood how these ocean gyres are formed in the different oceans. And this is what I was talking about. If you see here carefully and you focus your direction towards these moving arrows, then you can see how this is the Antarctic Circumpolar Current, the largest ocean current. Antarctic Circumpolar Current. The Antarctic Circumpolar, you can see how big it is. The Antarctic Circumpolar Current, it you know encircles the entire Antarctic landmass in a clockwise manner. It goes from west towards east, and then it encircles the entire Antarctica. So let us write about it. It encircles Antarctica. It is so big that it carries around 150 to approximately 200 SV of water. You can see the size of this current. This current is the reason for the presence of ice sheet over Antarctica. So we can say that the Antarctic Circumpolar Current, largest current, this is the ACC, Antarctic Circumpolar Current, it thermally isolates Antarctica. What does it mean? It means that this current does not allow the warm water from tropical latitudes to come near Antarctica. As a result, Antarctica does not get heat of the tropical oceans, and therefore it remains a cold continent. So the Antarctic Circumpolar Current, it thermally isolates Antarctica, and then this thermal isolation is the cause for ice cap, permanent ice cap over Antarctic landmass. It is the largest ocean current, and interestingly, the ACC, it forms it forms the southern margin of all the ocean gyres in southern hemisphere. So let me write for you the oceans over here. Yeah. So if you see carefully between South America and Africa, this is the South Atlantic Ocean. Then between Africa and Australia over here, this is the Indian Ocean. And between these two, this is the South Pacific Ocean. So we can see here how this ocean current, the Antarctic Circumpolar Current, it is operating in the as a thermally isolating current which separates Antarctica from the entire globe and does not allow the heat to come over here and is responsible for the polar ice cap. Let me now show you these things on that map. All right. So, first of all, let us see the currents in the Indian Ocean. You all should visit this website. It's a very, very helpful website. I'm talking about the Indian Ocean. So, if you see here carefully, and let me superimpose the sea surface temperature over here. Yeah. So, this sea surface temperature, of course, you can see this eastward moving current is the equatorial counter current, and the south equatorial current is this. These currents, see, they are moving towards the western side, east to west. So this current is the south equatorial current. This current over here, which goes along the coast of Africa and then meanders and then turns back, this current is the Agulhas current. It is the Agulhas current. This huge current over here, you can see this current encircling Antarctica is the Antarctic Circumpolar current. And this current, which is moving from south towards the north, this current over here, this portion, it is the West Australian current. So, in the Indian Ocean, this portion forms the Indian Ocean gyre. Now, let us come to the Pacific Ocean. First, the North Pacific. In the North Pacific region, if you see the direction of these currents, this water direction, it is the North Equatorial current. Then here the Western Pacific warm pool is formed, and near the coast of these Philippines, the Kuroshio current generates, and see how this Kuroshio current moves from these low latitude towards high latitude. And this extension of this Kuroshio current is the North Pacific current. And then in this region on the eastern side, if you can see these arrow movements, they are coming from high latitude towards equator. This is the California current. So this forms the North Pacific gyre 1, 2, 3, and 4. In the Southern Pacific region, this movement over here, all this water movement, this is the South Equatorial current. On the eastern margin of Australia, you can see this poleward moving current. It is the East Australian current, then the Antarctic Circumpolar current, and here near the Peru Chile coast. If you see here carefully, if I zoom it, then you will find this current moving over this one. This is the Peru current or Humboldt current. This is the eastern boundary current. So we get the North Pacific and South Pacific gyres. Let us now see the North Atlantic Ocean. Then this is the North Equatorial current. It flows over here. From the Gulf of Mexico, we get a warm western boundary current. This is the Gulf Stream. This Gulf Stream is carried further north by the winds. You can see these movements, the meandering pattern and these movements. This is the North Atlantic Drift. And then if you can make out clearly, then on this side near the Canary Islands, this flow of the current is over here. I am not sure if you can see it properly. This is the Canary current. So this becomes the North Atlantic gyre. And in the Southern Atlantic Ocean, if you see here carefully, this is the South Equatorial current. Then we get all along this the Brazil current, then Antarctic Circumpolar current, and then in this portion on the eastern side of the South Atlantic, there is this cold current, that is the Benguela current. So this makes us the different four currents which make up the South Atlantic gyre. The currents, they have these different properties. If you can make out, and you may get this question in your mind, why these currents they meander, why are they not flowing in straight path, then why just like the why just like the why just like a river, meandering river, as a meandering river forms oxbow lakes, why are these eddies over here? You can see from the main stream, lot of these eddies they separate everywhere. See this? These eddies they separate. Okay, the meandering Gulf Stream. All these I will discuss in the later class. So for now, this class is all focused on how these currents they operate, what is their direction, and what is the sense of movement. Okay, so I hope you will enjoy this lecture. Thanks a lot.